Now, since a market with public bats generates excessive amounts of production, a very natural question is which class of corrective policies can restore efficiency in the market by reducing the amount of production. We're going to consider the two classic policies that are used in the real world to deal with this problem, which are corrective or Pigouvian taxation and permit markets. So in this video, we're going to look at this corrective taxation. The policy looks as follows. A tax is imposed on every consumer or firm generating an externality on others. The tax is equal to the total marginal damage or total marginal externality at the optimum. And finally, the revenue is returned lump sum to consumers. Notice an important thing is that, for example, if a consumer is imposing an externality on both other consumers and firms, the size of the tax has to reflect that total marginal externality to both groups. Now, key result, this Pigouvian tax system leads to an efficient allocation. So if the government imposes such a corrective tax system, an optimal allocation would follow. Before I explore how this works, notice that these things are called Pigouvian taxes because Pigou was the economist that first figured this result out. Now, this beautiful result holds under very general circumstances, under very general assumptions, and certainly for all of the examples that we're going to look at in this course. But a general proof requires a lot of notation and gets too cumbersome. So to maximize the intuition, I'm going to look at simple case or model in lecture 9.1. And remember that this is a case in which the externalities, just to remind you, there are externalities from consumers to consumers. The utility function of the individuals would depend on Q, M, and E, and was simply BQ plus M and minus this damage function gamma damage of E, where E was the total externality, and the marginal cost of production was equal to mu, was a fixed amount. Okay? And also assume there are n consumers. So let's look at this case. What the Pigouvian tax system says is that we're going to use a Pigouvian tax, let me denote it by tau star, equals to the total marginal externality that is caused by every unit of consumption. So this is going to be gamma n, because this is how many consumers are affected, d prima, evaluated at the optimal level of the externality, Q optimum. Okay? And this is imposed on consumers because those are the ones generated the externality in this case. Now, what's the consumer problem? They have to maximize over Q greater or equal than 0, B of Q minus PQ minus tau star of Q minus the damage of the externality, and this is taken as given during the problem. Now this is going to generate first order conditions which look like B prima, marginal benefit, equals to the price plus the size of the tax. Now notice that in equilibrium we know that the marginal cost is a constant, so we know that the equilibrium price is going to be mu. We have seen this in many examples throughout the course for the simple case in which the cost function has constant returns to scale. So this implies that in equilibrium, every consumer, the utility maximization implies B prima equals mu plus tau star. But notice what tau star is gamma n d prima of Q optimum. And notice also, just to be precise, that in equilibrium everybody consumes the same amount, so this is B prima of Q total divided by N. Now, notice that this is exactly the optimality condition. In other words, when Q total is equal to Q optimal, we have that the total quantity is optimal. So by imposing the tax equals to the optimal amount, the utility maximization problem leads, plus the fact that in equilibrium the price is mu, lets the individual to satisfy the optimality condition. Let me show you the intuition of what is going on. Now, optimality requires that the marginal social benefit be equal to the marginal social cost. In this case, the marginal social cost is equal to the marginal private cost because there are no externalities on production, which is equal to mu. The marginal social benefit is going to be equal to the marginal private benefit minus gamma n d prima, and this is the total marginal externality or total marginal damage. Optimality requires that a quantity is chosen that this is equated to this. Now, utility maximization implies that the individuals are going to set B prima minus T star equals P, and this is by utility maximization, and that the firms are going to set this equals mu, and this is by profit maximization. Now, what happens is that this is the marginal private benefit, and if this is chosen to be gamma n d prima at the optimum, then the optimality condition is satisfied. In other words, the key insight of PIGU is that by introducing the tax and picking the right value, we could restore the fact that utility maximization and profit maximization will again lead to the equation of marginal social benefit and marginal social cost. Here's another way of seeing graphically what is happening here. We have the marginal private benefit, which is given by the demand in the market as a function of Q. Now we also have a curve, let's say something that looks like this, which is the true marginal social benefit, and this distance is the n gamma d prima, the marginal damage. Now we also have in this particular model that the marginal private cost is equal to the marginal social cost is equal to mu. So that leads us to have an optimal quantity here and an equilibrium quantity here. As always, equilibrium is at the intersection of the marginal private cost and marginal private benefit, whereas optimality is at the intersection of the marginal social cost and marginal social benefit curves. But this is the inside of PIGU. Now suppose that you introduce the tax so that the demand curve of the subjects switches by the size of the tax. So it's going to switch then by the size of the tax parallel. As we have seen many times before, individuals react. So this is pure the market with tax. If this tax happens to be equal to this distance, which is n gamma d prime at Q optimal, what is going to happen is that the new equilibrium is going to become the Q optimal. This is the Q equilibrium with T star, the optimal Pigouvian tax. They pass through here. Notice that a smaller tax or a bigger tax won't do it. It has to be exactly the size of the marginal externality at the optimal quantity. Let me highlight several important remarks. The first one is that the optimal Pigouvian tax restores efficiency, but the government can only do this if it has or it requires sufficient information to calculate it. Compare this to the case of the first welfare theorem, in which the market by itself, without any help, without any information by the government or a centralized party, was able to accomplish efficiency. Here, the government needs to know enough to at least know who to assign these Pigouvian taxes to and what its size should be. The second is that the model assumes, and this is an important assumption, that everyone produces the same marginal damage. But if this is not the case, say for example, because there are clean consumers and dirty consumers, then individual specific taxes are needed. And that requires even more information. So to give you a concrete example, suppose that half of the consumers produce twice as many externalities as the other consumers. They're twice as dirty, in an example of pollution. Those people require a Pigouvian tax that is always twice as large, and the government needs to have these individual specific taxes. The third remark is that the system works if tax is imposed to firms or consumers. It doesn't really matter, and let me show you why. So here we have the example that we just did, but in general we have the marginal private benefit, the marginal private cost, and suppose that we are looking at a case in which the marginal damage is on the consumers. So let's say we have that the marginal social benefit is below. We have something like this. We can restore optimality by either imposing the tax on consumers, which basically shifts their demand curve like this. This is their demand curve for the market with the optimal tax. And remember, this is the optimal tax. Or we can achieve the same thing, exactly the same thing, by leaving the consumers alone, but imposing a tax on producers that shifts their demand curve in parallel, so the supply curve in parallel up. So this will be the supply curve of the market with the tau star. This will be the supply curve in the market without tax. In both cases, we get that the equilibrium quantity is equal to the optimal amount. So it doesn't matter. Notice, however, that you cannot, it doesn't work if impose the full Pigouvian tax, tau star, on both. Why? Because in that case, you think about it, have the marginal private benefit, the marginal social benefit, you have the marginal private cost, the marginal social benefit. If you impose that tax on both of them, so you switch the demand here by this much and you shift the supply here by this much, you end up with an equilibrium that is here, which is less than the Q optimum. So intuitively, you only have to tax the transaction of every unit of Q that produces externality once. You can either by imposing the tax on the consumer or on the producer, but you cannot tax it twice.